Hello, my name is Andre Sponseller, and I'll be talking about Katmai National Park. The park is famously known for its many brown bears, active volcanoes, and for its unique geologic characteristics. Katmai Park was first a national monument in 1918 declared by Woodrow Wilson. This was for the sake of protecting the surrounding environment after the Nova Rupta volcano erupted in 1912. As the land began to rejuvenate with wildlife and resources, it was deemed that Katmai becomes a national park in 1980 in order to protect and amplify the park's natural wonders. The park offers 4 million acres that consist of various landforms such as lakes, mountains, and forests that are all homes to various species. Katmai National Park is on the south side of Alaska, located in the Alaskan Peninsula, within the active Aleutian Volcanic Arc, also known as the Pacific Ring of Fire, seen in Figure 3. This region consists of earthquakes and volcanoes all around the Pacific Ocean. The U.S. Geological Survey states that 90% of earthquakes and most volcanic activity in the world occur here. Figure 4 is a topographic map. It shows the volcanic terrain, lakes, and rivers found within Katmai Park. The map also features Valley of 10,000 Smokes, Brooks Camps, Brooks Lake, and Kamishak Bay, which are just a few key features within the park. Through the slides, we'll explore deeper into the history of Katmai National Park. Katmai National Park's geologic history began in the Cenozoic era, specifically in the Quaternary period. However, its foundation dates back to the late Jurassic Naknek Formation, a piece of the Mesozoic era. During this time, the region was primarily composed of oceanic sedimentary rock, which accreted over millions of years. Over time, the Pacific plate slowly subducted beneath the North American plate in the Miocene epoch. The pressure of this convergence reshaped the landscape in ways such as uplift on the land that formed mountains and increased volcanic activity. Figure 5 is a geologic map that shows different types of and ages of rocks found in Katmai National Park. Maps like these are useful to scientists to understand how the land formed over millions of years due to tectonic activity, volcanism, erosion, and glaciation. The west side of the park features numerous of glacial moraines along with alluvial deposits. These moraines act as natural dams, streams promoting the large lakes that define western Katmai landscape. To the east, the first mountain ranges encountered are primarily composed of sedimentary rock and intrusive igneous formations dating back to the early Jurassic period. As you cross the Bruin Bay Fault, the landscape changes. Rocks here come from the late Jurassic Naknek Formation. Mixed in are much younger volcanic rocks from the Tertiary period and Quaternary periods. This figure demonstrates how the region has changed over time. The Pacific Ring of Fire is a region known for its intense volcanic activity. One of the most impactful events in Katmai history happened on June 6, 1912, when the Nova Rupta volcano erupted in a Palean-style eruption. It filled the skies with ash that darkened Katmai for 60 hours. Figure 6 is an illustration showing the extent of ash coverage over the land. The eruption was so powerful that it caused the summit of Mount Katmai to collapse, forming the Katmai caldera. Scientists believe that the collapse was caused by 14 earthquakes, with a magnitude between 6.0 and 7.0, that continued on and off for 3 days. Layers of mud mixed with the ash from the eruption help confirm this timeline. The eruption has produced rhyolite, dacite, and andesite. It also produced pyroclastic flows which settled over the Valley of 10,000 Smokes, leaving layers of pumice and ash. It covered 40 square miles in volcanic deposits and created steam vents that filled the area with smoke. After the eruption, a lake formed inside the caldera. It was 10 meters deep in 1916, but in 1923 it drained away. Since then, it began filling and is 250 meters deep today. Figure 7 shows the Nova Rupta lava dome, which was formed inside the volcanic vent after the eruption. Lava slowly extruded and solidified, which created a rounded feature. Katmai's landscape is continually being shaped due to the effects of glaciers, erosions, fossils. During the Pleistocene epoch, glaciers reshaped the land as they moved across it. Mountain peaks were covered by thick ice blankets and ice fields. Glaciers moved down from the mountains and over the land, shifting rocks and transporting sediments far from their original locations. When large pieces of glacial ice began to melt, they left small depressions that filled with water, resulting in the formation of kettle lakes. There are still active glaciers in Alaska, but climate change has caused a significant decline in glacier coverage. A study conducted by Giffens, Hall, and Sheehan from 1986 to 2000 showed a 7.7 decrease in glacier across Katmai. This decline continues today. From 1985 to 2020, Alaska has experienced a 13% decline in glacier coverage, while Katmai experienced a 16% decrease. Figure 9 demonstrates the ways that how glaciers reshape the land as they are melting away. Shown in Figure 10 is that active glaciers are still present, but with rising global temperatures, glaciers will continue to retreat, causing water levels to rise in the future. The Nakanak Formation, which dates back to 160 to 146 million years ago during the late Jurassic period, contains a significant amount of fossils. Fossils from the Cretaceous period were also found, showing Katmai's diverse and extensive natural history. The fossils found included bivalves like scallops, shown in Figure 12, gastropods such as sea snails, and cephalopods like ammonites, shown in Figure 11. Before Katmai was established as a national park, four indigenous communities claimed the land as their home. The people of these villages hunted, fished, and relied on natural resources. In 1912, the eruption of the Nova Rota deemed the region uninhabitable, and the villages were forced to abandon. Figure 15 is a village in Katmai in 1912, depicting how uninhabitable the region was. After the eruption, members of the National Geographic Society were the only people visiting the park, making 7 trips to the eruption site from 1912 to 1919. After the society published their findings, Katmai Park's tourism started to increase. In 1950, a full-time ranger was stationed in Brooks Camp, which led to tourism to increase drastically, resulting in several camps in the park being established. Figure 13 shows the relationship between visitors and bears. In the present day, the results for visitors has changed. Remain 50 yards from a bear and never run. These rules don't stop interactions with the bears. There are bridges that are high enough to feed the bears safely so we can interact with them, as seen in Figure 14. The geologic history of Katmai National Park and Preserve was something that I am glad I got to learn about so in depth. The park has experienced tectonic uplift that created mountain ranges and became the site of the largest volcanic explosion in history of the 20th century. These geological processes shaped the landscape and laid a foundation for the park to have a thriving ecosystem. Thank you.